Hello and welcome to the Alumni Research Talks, brought to you by the Computer Science Association here at BITS Pilani. Our speaker for today is Aruna Balasubramanian, who is an associate professor at Stony Brook University. She received her PhD from the University of Massachusetts Amherst in 2011. She works on a diverse range of problems, including improving smartphone accessibility for users with disabilities, improving web and video quality of experience, and making cloud applications more private. Her work is widely used and has garnered over 8,000 citations. She is a recipient of several awards, including the SIGCOMM Dissertation Runner-Up Award, the UBCOMM Best Paper Award, a VMware Early Career Award, and the Applied Networking Research Prize. She is passionate about computer science, more inclusive, and she works on projects on broadening participation in computer science both within and outside of Stony Brook, for which she received a Mid-Career Faculty Diversity Award. And she's also a graduate of BITS Pilani, and she graduated from 2002. So welcome, Professor. I'll let you take the stage.
Hello, thank you very much for that introduction. Let me first share my screen. Okay, is this clear? Can everybody see the screen? Why can't I? Okay, there it is. Okay, now I have expanded my screen, which means I can't see anything else on IR Meet. So if anybody can please unmute and just tell me that if you can see what's on the screen, I can start.
Yes, ma'am. We're good to
go. Okay. All right. Thank you to the Computer Science Association for inviting me. This actually, the last couple of days, I've been reminiscing about my time at BITS, and so this was a great opportunity for me to do that. And I'm actually very, very excited to be here, to be talking to you all. I only wish that we were doing this in person, but maybe some other time. Actually, next year is our 25th reunion, so maybe I'll get to see many of you then. So my name is Aruna Balasubramanian, and my ID number back then was 97A6C6338. I don't remember the last time I used that, but there it is. It actually came back to me when I was thinking about this. So I'm going to start with a little bit of background. So like was mentioned, I was at BITS from 97 to 2002. I was a dual degree, MMS and Information Systems. I don't know if these degrees are still there at BITS, but anyway, that was what I was studying. After which I did my master's at the University of Buffalo, and then a PhD at UMass Amherst, followed by a postdoc at the University of Washington. And after all of the studying, I became a faculty at Stony Brook starting 2015. And just this January, I was promoted to an associate professor. So that's sort of my journey. And it's, of course, looks like I've only been in academia all through, which is true, except that I had like few internships, 3 internships specifically at Microsoft Research in Redmond when I was a PhD student. And so I have maybe some taste of what the industry looks like. Not a lot, of course, because MSR is different. But I also noticed that you have Ganesh Anantanarayanan, who's going to be talking at this venue again. And he was also a BITSian. I didn't know him when he was at BITS, but we did an internship together at MSR, and we became friends. And actually, we even traveled together to a conference in Poland. So and he does amazing work. So I'm sure you'll enjoy his talk. Anyway, so let's come back to the talk itself. So the lens I'm going to use for this talk is as follows, right? And I know that this is not going to be too interactive in the beginning, at least, because I can't really read any questions, even if you ask. But I planned for it to be not very technical, but you can stop me anytime anyway. So if there's a burning question, then whoever's organizing it could basically just mute and ask the question. The other thing I wanted to say was I actually hate giving advice, but I'm going to do this anyway. And the reason I hate giving advice is it depends so much on your situation and so many other factors that like, one advice almost rarely can be applied everywhere. In fact, I'm actually going to give you contradictory advice. But I'm going to do this because I want you to know that it's possible to have contradictory advice. because everything depends on exactly what situation you are in at a given point in time. Anyway, so that's the lens for this talk. Okay, let me start with, so when I was going to give a talk at BITS, I basically have an album with me, and I was looking through it to see if I can find some photos. And all the photos I could find were just like us goofing around in our hostels. I couldn't find a single photo where we were doing anything even remotely useful. I couldn't find a photo of us in the institute or studying or anything. I asked my wing, so I don't know if wing is still a concept in BITS, but this is the set of people you live with. And they didn't seem to have any photos where we were doing anything that was remotely useful. And so anyway, so I got some photos which I thought were not too bad, which I wanted to show. This is of course the entrance of BITS. Here is a photo of a bunch of us standing outside the institute. I have no idea what we were doing here exactly, but yes, there we were. Here, this is one of my favorite photos. I think this was taken on the MB night, which is all of the girls. We're all dressed to the nines, which is obviously not always the case. And I really like this photo because we all just look so young and happy. And finally, here is a photo of the MMS group. Again, it's probably some kind of an occasion because we were all dressed decently. And we're standing in, I think that's the sky. But anyway, so the point of all of this is to tell you that suffice to know, I had a lot of fun when I was at BITS. We did do some studying, of course, but it involved a lots and lots and lots of goofing around. And I hope you all get to do the same. Okay. Anyway, so but the question is, was I interested in research when I was at BITS? And not really is the answer. And the reason for this is that, first of all, I didn't actually even know what research meant back then. I think you all are much more informed than we were 20 years ago. And I didn't know what a research career was. I didn't know what it meant, what it meant to do research. I had no idea about any of these things. However, the courses were very thought-provoking. For example, we did not just learn programming. We learned a lot of logic and algorithms. We learned why we were doing the program a certain way or why the construct was a certain way. We did C, and we basically learned a lot of memory management. And so it was, the professors made it really, really interesting and thought-provoking. And this is not just for the programming courses. There were other courses also that were not in my CDCs, which were also very, very thought-provoking. Of course, there were courses I hated, engineering drawing, for example, but it was more because I was not good at it and less because the professor did not teach well. And so I thought that is one standing moment for me when I think about my life at BITS. And in fact, when I teach the undergraduate course now, I always think about what kinds of things that I liked when I was a student that I can actually emulate. I also spent an inordinate amount of time at the IPC. I don't even remember what the IPC stood for now, but this was the room where there were lots of computers, and you only had of course, there's no GUI or anything like that. You used VI, but because the programming courses especially were hard, I spent a lot of time there fiddling with things and learned a lot in the process. And so I got really interested in computer science and programming just because of that. And I was also part of this group called the Paper Evaluation and Presentation, or PEP. I don't know if this still exists, but this was a group that there was this technical festival called Apogee. I think it's still going on. And the idea here was that you actually get papers, people submit, and then they give presentations, and you have professors come and judge them. And so I had some sense for what a paper presentation could be. Of course, I didn't know anything about it, but it was still, I could see the process. And so I think some of these were instrumental in getting me where I am. And I also got introduced to networking and some serious programming. Back then, there was this professor, Rahul Banerjee, who taught networking, Ray Ban, he was called. And he introduced us to projects that were brand new. So, for example, this was in 2000, right? 1995 was when IPv6, the new version of IP, was introduced. And it wasn't clear how well it will work or how it can be deployed. There were these dual stacks, one of them for IPv4 and IPv6. And we already, as undergraduate students, just 4 years after its launch, were doing some projects on IPv6. We also did some projects on Kerberos, which was a relatively new security protocol back then. It was a network security protocol. And so these also, I got introduced to some networking projects that were beyond what I was learning in class. I also had another professor, UVS, Usha Subramanian. She was just a charismatic professor. She taught us programming. I loved it. We also did a lot of interesting elective courses. So back then, there were master's and PhD students at BITS who used to teach classes. And they were much younger, right? And they were maybe a couple of years older than us. But they were so enthusiastic. They will tell us about like the industry and like what an architect does and what does it mean to do a large scale project. And they just made this whole thing sound so exciting. So I can't thank all of these people enough to lay a really good foundation. Anyway, but the point was that at this point, I had no idea about what research was. I had like no intentions of doing any research. But what I did know was I did not want to get a job at that point, because I think everything I had done at that point, except for apart from the goofing around, of course, sort of, I got the sense that there was more to it and I wanted to learn more. And also, of course, people around me were all applying to do a master's. So I decided that that's what I was going to do as well. And so I went to University at Buffalo. And the two biggest things that stand out to me when I was there was this algorithms class that I took from a professor called Hung No. He has since left Buffalo, I just noticed. I met him a few times after my time at Buffalo. So I found this course fascinating. I had done an algorithms class in BITS, but I had never done it with so much rigor. I also took other theory courses with him, and I realized that I was actually pretty good with theory. And it's sometimes you don't realize that you're good at something, and when you do realize it, it's a good feeling. I also did some initial research. There was this project that I was working on network security that we wrote a grant and got a funding from NASA. And so I had some taste for research. I wasn't, by any means, I didn't really know the research method well, but I was working with some really good researchers, and I learned the beginning parts or the preliminary parts of the research process. And so what happened then was that I realized, okay, so that I did not really, it was not like when I was at BITS where I had no idea. Now I had an idea, and I really wanted to do this for a living. And so I applied for PhD programs, and I went to UMass. Really, UMass is where I would say that my research journey started. In fact, the very first class I took at UMass was How to Do Research. That was the name of the class. It was just eye-opening. We read a lot of classic papers. It was a lot of philosophy involved. I had up until then been very STEM focused, but then I read these philosophy papers, which just opened my eyes to the research process itself. I started really liking the research process. So anyway, so let's dive into the project I did for my PhD. The project was under the umbrella of what is known as delay-tolerant networks. So you should cast your eye back to 2005, right? You probably were all in elementary school at that time. Or maybe, I hope you're all born. Yeah, you must have been born by then. So back then, cellular was not available prevalently. There was, of course, phones, but these phones were mostly used for calls. They were not used for data. And if you did get some data available, it was very, very small, so it was not very useful. And so one of the ideas that people had was that given that there's no infrastructure at all, of course, Ethernet was very good. So if you're at home, you'd get reasonably good internet access. Wi-Fi was coming up, but Wi-Fi was mostly used at homes just so that you can be not tethered. And so the idea was that, well, what if I can tolerate delays, right? So take the example of email. I send an email. I don't really need to get this to the other side within seconds. If it takes, like, say, a minute, that's fine. It's not a big deal. Or like even some huge file transfer. Maybe it will take you a few days. Maybe that's okay. And so that was the idea behind delay tolerant network. So the idea was that if I assume that my application can tolerate delays, then can I build a network without end-to-end connectivity and without a lot of infrastructure support? So an example of this is KioskNet. So here, for example, the idea was that you'll have these towns. Each town will have a kiosk with a computer, and there'll be like vehicles that are running between these towns. So when the vehicle comes, and the vehicle has a Wi-Fi access point and a computer, and when the vehicle comes close to the kiosk, you exchange all of the information. And then you go to the next town and so on, up until you go to the city, where you probably see an internet. So the vehicle will be close to an access point that's connected to the rest of the world, and you would download all of this from there. And so this was a project that was done at Waterloo. Another project was called Cartel. This was done at MIT. The idea here was that you have cars that are cabs that go around, and maybe they're collecting some information, let's say of accidents, but they can't send this anywhere, right? Remember, the cellular connection was not available at this time. And so the idea was that if the two cars pass each other, then maybe they can exchange some information, and that's how you'll spread this. And another example was animal monitoring. You could potentially do this for animal monitoring. You can have these microcontrollers on animals, and when they pass each other, they exchange information until it gets to one end. Right? And all of this, remember, was done because infrastructure was not available or it was expensive. Actually, it was not even available. It was not even expensive. That was not even the point. Anyway, the question was now, how do you route here? Because remember, I don't know how many of you have taken your networking class, but the way routing works today is you have a router, it has input ports, output ports. A packet comes into the input port. You figure out, you look at the routing table and say, what's the best place to send this to? And you switch it to the output port, you're done, right? Now, that's not the model we can use for DTNs, because when I get a packet, well, I don't really have anybody to send it to. I have to wait until I meet someone else and send it to. And so the idea was to use a post office model. Okay, so the idea was that, let's say XYZ are vehicles or some kind of like something that can move. When X and Y meet, you exchange this data, and then when Y and Z meet, then you exchange the data, and you're done. And in fact, most routing protocols added a layer of replication to this. So rather than when X and Y meet, you just give the packet. Instead, you actually replicate it. So you keep a copy of the packet, you give the other one to the other person. Right? And so this was sort of the idea was to flood. And of course, this is not very effective, because like if you keep flooding the network, then you're just going to have the same packets over and over again. So we wanted to work on this problem. Brian and Arun were my advisors back then. And the interesting thing was that so Brian at that time was working on building a DTN network in Amherst. So he had these buses and he wanted to connect these buses together. Arun was more theoretical. He was very interested in seeing what was the theoretical problem in DTNs that we were trying to solve. So when I joined, remember I told you that I was good with algorithms and just theory. So I decided that because I was good at that, I was going to tackle this problem from the theory point of view. And so especially what I was telling them was that now the routing problem itself is very different, right? The routing originally in an end-to-end internet, the routing problem is that given a packet, what's the next best hop for it? That's not the case here. Here, the problem is not what the next best hop is. When I meet somebody, they are my only choice, right? So the ideal thing to do would be to just send everything I have, make a copy, and replicate it to the other person. The problem is that it's a very short-lived connection. Imagine two cars that are going past each other. They don't have a lot of time to send data. So if I have, let's say, 1,000 packets, The question does not become like who's the next best hop, but rather which of those 1,000 am I actually going to send? So take this example. Let's say there's a packet and it becomes useless in an hour. Okay. Now, if I have that packet in my buffer and it's like 59 minutes, there's no point in replicating this packet because it's not going to get to the destination within an hour. So that's a waste of my time. And so what we soon realized was that how you make this routing decision also depends on what you're trying to optimize. Are you trying to optimize for minimizing your average delay, minimizing worst case delay? Are you want to send everything before a deadline? What is it that you want to do? And so we designed this protocol called Rapid. This was my first work that I did as my PhD. And this was a very theoretical at this point. It took a year, but it was about how do you define a utility for each packet replication and say, which is the packet that will have most utility to replicate. So let's say, for example, that A and B meet, and there are two packets. One is meant for C, the other is meant for D. Now I know that B is going to meet C very soon, but it's not going to meet D at all. In that case, then it's much better to replicate the packet that's meant for C than to D, because the utility of this replication is high. So that was our main idea here. And Arun was, like I said, had a really strong theoretical background. So with him, we proved a bunch of theorems and we came up with this like routing protocol that can maximize marginal utility. However, Brian, who's my co-advisor, was not very happy with this. He said, well, this is awesome. I love this protocol, but unless you show me that this works, this doesn't matter to me. Oh, by the way, I just wanted to say the first thing was to play to your strengths, right? If you're good at something, try and do that because it's always good to play to your strengths. But, and the very next slide, I'm going to tell you the exact opposite of this, which is how advices go in general, right? Okay. So what he said was, well, we have these buses, and I've put computers and Wi-Fi access points there. So, for example, on the whatever the thing is called, the hood, or no, it's not the hood, whatever the thing is called. There is a power converter, an access point, a computer, and whatnot. There were 30 of these buses. They were running about 10 square mile area. So what you're showing here, the red dots are places where two buses meet each other. And he said, deploy a protocol on these buses and then deploy another protocol, whatever is used for routing, and show me that this one is better. Rapid is better. Although I was good at programming, I wasn't really good at programming at this level because remember that if something goes wrong, I put something on my computer and my computer crashes, I have no way of debugging this. Because, like I said, it was just, there was some feeble connection that you could have to the buses. The buses would send pings every now and then, so I knew it was alive or not, but not much more than that. And so I was very uncomfortable with this, but pretty much I said, fine, I'll do this. I remember a lot of times I'd be sitting in this bus terminus waiting for the bus to come back because I know that it was malfunctioning. I actually knew all the buses' names by heart. I knew when they will be at the garage. In fact, the people who worked there, initially they were very suspicious of me because they didn't know what I had to get a piece of paper and keep showing them. But soon they knew who I was. And so I had to actually get this thing down and do debugging. It was just a nightmare. But the thing was that I learned a lot from this experience. The first thing I learned is being able to show that something works in an actual prototype is 1,000 times better than just showing it on paper. And the second thing I got was confidence that I could do this, right? And so the takeaway is just don't be afraid to learn new skills. And again, like I said, it's directly contradictory to what I said in the previous slide, which was play to the strengths. But again, that's how advices go. It really depends on the situation. Anyway, so we wrote this paper up, and unfortunately, this paper did not see immediate success for various reasons, right? We had to first convince that this was a good enough DTN. We had some proofs, but they wanted more proofs. And by this time, I was about 2 years into my PhD, a year and a half into my PhD, and I had nothing to show, and I was starting to get very frustrated. In fact, I remember like walking into my advisor's I'm hearing some noise. I'm not sure why. Is anything the problem? Okay. And so, and he said that why don't you work on something small and write a workshop paper, but don't sell this paper short, right? And what selling the paper short means is that we were trying to submit to first-year conferences, and I was saying that we should just submit to a not first-year conference and get it over with. But here's the deal, right? When you get a paper into a first-year conference, it's not just that it's a bragging right. It's not that, oh, look, I have a paper at this conference. That's not the point. The point is that more people will read your paper if it's in a top-tier conference, which means that more people will know about the work, they'll cite the work, they'll use the work, and your work will actually have an impact. And so that's what Arun told me. And so I said, fine. And then we held on. And actually, the paper got published at SIGCOMM, which is one of the top conferences in networking. And it actually became very popular. You can see Wikipedia articles about it. There were blog posts about this. There were news articles. In fact, actually, if you look on DL, you'll see that it's been cited about 1,300 times, 1,300 times. So this is still one of my most well-cited, well-used work. And so the takeaway here is don't sell yourself short, right? If sometimes this happens in research, actually a lot of times this happens in research where you're working on a problem that's not quite, the environment is not quite right for the problem yet. People are not still seeing that this is a problem. So it's your job to, first of all, make sure that people see this, but then things turn, and when people start seeing that this is actually a problem, then it becomes very popular. And so sometimes patience is actually always, I guess, patience is a huge virtue. The question is to knowing when you should wait and when you should not. And again, I'm going to give you an example where it's probably not a good idea to wait and just give up this okay. I'll talk about it in a few slides. But anyway, so now that was my first work, and then I started doing a lot more work in this DTN space, and it became eventually my thesis topic. And the first thing I did was with my friend Jacob Sorber. So Jacob was a fellow PhD student, and he was really, really good with CPS or cyber physical systems. Like, he was very good at building things and figuring out like what best way. For example, he was working on how do you use solar power to power microcontrollers for days on end. And he was working on this project called TurtleNet, where he had these microcontrollers on these turtles, and they were wood turtles, I think. I don't remember the ecological parts of these projects because this was Jacob's project. And the idea was that they wanted to see where they moved around. So they had like a small GPS. And the idea was that you could actually figure out what their habitat was. And there were ecologists involved in this. They were very interested in this project. And the way Jacob was doing this was he had these lightweight microcontrollers on these tortoises or turtles. And when he had like this one access point at the end of the forest. And when they came to that access point, he could get this data. If not, he'd wait for a year, go and capture those turtles and get this information, and then free them. So when I was talking to him about Rapid, he said, what if we can actually do something like that for these turtles? And we thought this was a good idea. We had to tweak it a little bit for this environment because the amount of space we had for the code was small. But then we worked on this project, and I really, really enjoyed working on this and expanding this Rapid to turtles. Another synthesis project, this was with another colleague, Aruna Balasubramanian. He's actually also my husband. But so again, remember back then, there was no cellular connectivity. So when you sat in the bus, you couldn't actually scroll. Actually, there were no phones. So there was no, there were phones, but you couldn't really do data on your phones. And so the only way to do anything was to use a computer, but then you couldn't connect anything to the computer. So Niranjan was working on web search. And by this time, Brian Levine, my advisor, he actually he was a doer, right? I told you from before. So he had deployed these mesh networks in our downtown. So there were access points all over the place. So Niranjan explained to me how web search works, and my idea was, what if I can actually do search from the bus using these access points? Because they were, unlike the other scenario where I talked about, where you may not see a bus for hours on end, here a bus would see an access point every few seconds, and in the downtown area. So the idea was, can I do web search from a bus? And so that's the project we did. We called it Tedu. I don't know how many of you are Tamil in this audience, but Tedu means search in Tamil. And the idea for the name came actually from Brian. So because we were Arun and I were both Tamil, and Brian said, "Hey, there are so many papers with the Greek names and Roman names. We both are Tamil. Why don't we call it some Tamil name?" So we decided to call it Tedu. Okay, so I was chugging along, and then there was a wrench in my plans. Okay, this was in 2009, and I was at Microsoft Research. The previous year, I had also been at Microsoft Research, and we had worked on how to do Skype from a bus, right? If I have how can I do do extremely interactive applications using this Wi-Fi access. Again, you have to remember there was no cellular this time, right? And so I went to the following year, and I was starting to work on an even bigger vehicular Wi-Fi project. And it was like massive scale. We were trying to figure out, we were talking to the bus companies and trying to figure out how we can do this citywide network. But then this happened. Right? I don't know how many of you remember this, but this was when 2007 is when iPhone was introduced. When iPhone was first introduced, I didn't quite realize what the impact was for my work. Right? Because iPhone was a phone, fine, whatever. But what happened was that there was a huge demand for cellular access because this iPhone was just so handy. Because the phones before, they were so clunky that even if you did have cellular access, it was such a pain to look for things that nobody bothered. iPhone changed everything. Because of which the use case for having blanket cellular connection became very popular. So everybody now, cellular suddenly available everywhere. So when I actually went to pitch this project with the manager at Microsoft, to Victor Ball, he was the lead researcher at that time, he said, "This is fine, but in a few years, you're going to see cellular anywhere, so who cares?" This was a heartbreak moment for me. Because this project I was working on at that point was depending on vehicular Wi-Fi, but also everything I've done up until that point was on vehicular Wi-Fi, and it was all going to naught. I thought about this a lot, and I still worked on it for a few more months, but then I decided that I was going to scratch that project. I could not. So here is the deal with research, right? It's one thing to convince others that what you're doing is important. But if you can't convince yourself that what you're doing is important, then it's impossible for you to continue with this. It's just impossible. So I struggled a lot, but then I scrapped that project, and I didn't want that to be a complete waste. So I sort of pivoted with my research mentor there, Atul Mahajan. And instead what we did was build something called Whiffler, where at this point, what we said was, okay, fine, there's cellular. I give up. You're not going to use vehicular Wi-Fi anymore. But it's possible that cellular will be overloaded, in which case you might want to offload to Wi-Fi. And so we still stuck to our vehicular theme, and we said, what if I can figure out how much data I can offload to Wi-Fi, so as I'm moving, I will still have end-to-end connectivity, but so that I don't actually have to use my cellular so much. And surprisingly, this project became popular because back then it wasn't like people were not thinking that cellular is going to be overloaded. But this is the nice thing about academia, where you can actually work on projects on problems that is going to come in a few years. And so, in fact, we talked to T-Mobile after this project. We talked to AT&T. They were very excited about this. And in fact, now offloading to Wi-Fi is a very common thing that cellular providers do. And so I was very happy to have worked on this now in hindsight, even though back then I was just really, really pissed that all my work went to waste. So the takeaway is learn when to abandon a project and pivot, right? And like I said, with the rapid work, we stuck to it. But here, I abandoned it. And why? I think the reason is your gut, right? If you can convince yourself that this is a good project, you should continue. But if you yourself can't convince yourself that this is a good project, there's really no point in doing it. Anyway, so this was my dissertation. That's my advisor, Arun, introducing me. It was finally about how do you design protocols for various levels of disconnections, right? Like when you have really long disconnections, when you have short enough disconnections that you can do search, when you have extremely short disconnections, when you can do things like Skype. How do you do that from vehicles? That was my PhD topic. And in fact, the dissertation won many awards. It got the Outstanding Dissertation Award at UMass, and also it was a runner-up at the SICOM Dissertation Award. But the point was that I was done with vehicular Wi-Fi. Right, I'd done all this work, and I still felt that I want to work on something else. And again, this happens a lot. I don't have a takeaway here, but this happens a lot in research, in that it's impossible for you to optimize what you're working on what's going to be popular. You should just work on what you think is important at that time. Right? Things may happen, it may not happen, but it's okay. The good thing is that the ideas that you have developed and the skills that you've learned, they will go along even for your next project. Okay. So now the year was 2010. I'm already 35 minutes in. I was hoping that I would be faster than this, but anyway, that's fine. I had finished my PhD, but the US was in the middle of an economic crisis. This was, I don't know how many of you remember how bad 2010 was. You probably were all in middle school then. But the academic jobs were few and far between. I did get a few faculty offers at this time, but they were in really remote places. My husband was still doing his PhD, and we didn't know what he would do at those places. At this time, I was pregnant, so being apart was not an option. And so we thought a lot and thought maybe that I would go to the industry for a few years and then come back to academia. And I did a few interviews, and I just did not, my heart was not in it. In fact, I remember very clearly I had gone for an interview. I'm not going to say where, and I just was so disillusioned that I drove back. I didn't even go home. I was 6 months pregnant at this time, so I might have been hormonal. But I drove back to my school. I walked into my advisor's office, and I said, I'm done. I don't want to get an industry job. Find me a postdoc. And my advisor, he's unflappable. He said, okay, where do you want to go? And so I actually ended up getting a fellowship to do a postdoc. The NSF, at this point, because the US was in the middle of an economic crisis, NSF came up with these fellowships. So they'll give you money to do a postdoc. And in fact, interestingly, this fellowship has been renewed. It stopped after a few years, but then it has been renewed now because of the COVID epidemic. And I'm on the steering committee. And so it's really nice that there's this opportunity for people who want to still be in academia but don't know what to do given the economic situation. So I was a postdoc at UW. Like I said, I did not want to work on vehicular networking anymore. And I also found that the environment at UW was very different from the environment at UMass. And this happens a lot. And this is why people say when you do research, it's good to go to different institutions, because the institution's culture and what they focus on is so different that you learn a lot of different things when you do this. So UMass, for example, was very networking and networking focused, whereas UW was more distributed systems and systems, operating systems focused. The other thing about UW was that Google was close by and they had a lot of ties with UW. So in fact, like the Google researchers would be there at UW a lot of times to attend talks. They talked to us a lot. And so I actually got to talk to them, and so that was another, so that opened a new research environment for me. So I decided to completely change my research focus. And at this time, there was another graduate student. She had done her internship at Facebook, and she had come back with some new ideas as well. And so we decided to look at this new topic called web performance, right? And it was completely new to me. I had done nothing. I didn't know nothing about web or web performance. Actually, I barely written a web page. That was the extent of my knowledge. But I decided that was the time for me to reinvent myself. And this is a very nice thing about academia, is that it gives you many, many opportunities. Actually, this is not just academia. Probably industry, this is true too. But it gives you many opportunities to reinvent yourself. And when you feel you're in a rut, it's probably a good idea to reinvent yourself. Anyway, so web page loads, as I learned at that time, it was very, very critical, right? Just a second delay in your page load time can cause a lot of loss for your company. And if you're a top company, like let's say Amazon, it's fine. You have a lot of engineers that you can put on this project and make sure your web performance works well. But if you're a smaller company, then it's going to be very hard for you to figure out what's going on. In fact, if you look at the mobile search, right, on the search, if your page is not well performing, it is not going to show up high in the search rank. So this means that let's say you're a small startup company with not a lot of money to design good web pages, then not only is your web page going to perform poorly, but people are not going to be able to even find you. And of course, there were lots and lots of ideas to solve this, right? To make your web pages faster. I'm sure if you've done any web coding, you know this. Like these, statements like, oh, put your JavaScript at the top, no, put your JavaScript at the bottom, no, put your JavaScript in the middle, no, make it asynchronous, no, don't make it asynchronous. Just lots and lots of ideas. But the problem is there's no one idea that makes you that can optimize your page. And in fact, an idea that or an optimization that helps the page can actually often hurt another page. And when we started looking at it, we realized that this was because of how complex your page process was. And I mean, I can go on about this for hours, but I'm going to make it very, very sparse here, or crisp here. So what happens is that you're going to be loading pages. At the same time, you're also computing things like JavaScript, and also you're rendering. Some of these can happen in parallel, whereas some of these things can have to happen one after the other. And when they have to happen one after the other, what happens is that you have, there can be bottlenecks. So for example, if I have to finish A before I finish B, that means if A takes a lot of time, then it's going to be a bottleneck. It's going to cause page load performance, poor page load performance. And so if I optimize A, that means I'm going to optimize the page. However, for another website, if that same A process is not on the critical path, it's not the bottleneck, then by optimizing it, you're going to get nothing. That's exactly what is going on. So here is an example. I was actually going to make this more interactive, but I don't know that that's a good idea here. So let me just not make it interactive. I'm just going to go on. Here are two web pages. Okay, the first web page on top, you have a JavaScript called B that's loaded, and then an image called C that's loaded. And then if you look at the same website in the bottom, you have the image that's loaded first, and then the JavaScript is loaded next. And let's assume that these are all exactly the same size, right? Now the question is, will one of them load faster than the other? And I always ask the audience this question, and usually it's about 50-50. Actually, I should say 30-30-30. 30% say there's no change, 30% thinks one of them is bigger, the other 30% thinks the other is bigger. But let me tell you what is happening. Right? When I load this page, my HTML gets first loaded, and then the JavaScript gets loaded, and then it gets evaluated. And then my image gets loaded. This is because, well, I'll get to that in a bit. So, but if in the second example, my HTML gets loaded, my image gets loaded, right? But the JavaScript gets loaded in parallel and gets evaluated. And so the second is faster than the first. Why? Because HTML depends on JavaScript completion. So until JavaScript completes, there's a dependency there, and so only after it completes can it load the image, whereas in the second example, there is no such dependency. Now, why this is the case, I'm not going to get into it, but the point is that what we did, there are many of these dependency policies that would tell you exactly why something is on the critical path versus not. And so what we did was we would load all sorts of different elements, and then we insert dependencies, insert delays, and see whether by inserting the delay, the page load increased. And by doing this, we were able to build a set of dependency policies that said that this is what, and of course, then once you build the dependency policy, we go back and see whether that policy makes sense, whether the dependency actually happened and there's a reason for it. And so we did this for several combinations and learned these dependency policies and came up with all of these dependencies. And what we then did was build this tool called wprof that sits on top of your browser, and it will work for many different browsers. And what it will do is it will load the page and figure out the dependency and tell you exactly what your bottleneck is, and tell you what the critical path is. So an example is, here is an example, very simple example. This is what wprof will give you. It will tell you that these are all of the things that are happening. The red, I don't know if you can see the red, so these red elements are those that are on the critical path. And what this means is that if you are on the critical path, that means that if I optimize that particular element, for example, in this case, JavaScript download, then I'll be able to optimize this page. But if I optimize something else like the image download, then I won't be able to improve the performance. And we've done a lot of things with wprof. It has spawned a lot of research projects in my group. I'm just going to talk about two. The first one is the paper we call How Speedy is Speedy. And this was, so Google at this point had a new protocol called Speedy that is now become HTTP2, which is almost every one of you is using this if you use the internet. And it was supposed to replace the previous version, HTTP 1.1, but nobody knew how it worked. So Google had some white papers that showed that it worked great, but they were not really rigorous. They were not for different conditions. And so what we did was used wprof to figure out when it worked, and it actually did work really well in certain cases. But the good thing was we were also able to find out the failure cases, right? We were able to find out when it did not work well. And this research was helped a lot by the fact that Google was next door. So we could go talk to them and ask them, like, if I send an email about, hey, here, you show this in your white paper, but, I don't really understand how you got this, then I can just walk in and they'll tell me how. And I have to say that Google was very cooperative about this, and they helped us a lot here. But we were able to do this study about a brand new protocol, but nobody knew how it worked, and showed when it failed. And in fact, it won an Applied Networking Research Prize. The other thing we've done is we've actually now, this is in collaboration with Google, but we've released this tool as a Chrome developer tool. We got some grant money from them. And so now, actually, you can go to wprof-x. I would like to have shown you the demo, but I don't want to risk doing something on here that would break this flow. But or you can come talk to me or ask me questions and I can tell you how this will work. But you can go to wprof-x and you can load any page you want, and you can actually see this dependency and the critical path. So you yourself, for your own pages, can figure out what is happening when you load the page, and you can improve the performance. Right? And so the takeaway here is you should leverage your environment. I use the fact that Google was close by and that UW had a different research culture. Anyway, so I'm down to my last 5 minutes of the talk. So I finished my postdoc and I joined as a faculty at Stony Brook. Here is my lab, NetSys, but actually this is severely outdated because 3 of the students here have already graduated with their PhDs. And in fact, I have two new students, Rebecca Drucker and Prerna Khanna, who's just joined, Prerna. And the focus of our lab has been, basically everything I've learned so far I've tried to put into use. The first thing is that we do a lot of interdisciplinary research. I've realized that actually not being scared to learn a new tool is a very, very important characteristics of being a researcher. We work with psychologists, we work with HCI researchers and NLP researchers and everybody. And we also are not afraid to buck the trend. So for example, now the trend is do everything in the cloud. But one of the projects we're doing is say no to the cloud, do everything locally on your device. I've also been working a lot on projects that are focusing on societal impacts. And this again is because of the environment I'm in. There's a huge accessibility group here. And also our medical school is very good. So I've been working on how do I make my smartphone accessible to users with different kinds of disabilities. So for example, if I have a smartphone where I have to use my fingers, and somebody has, let's say, some kind of muscular atrophy, and they can only move their heads. And how can I automatically make their head movements and input to the same application without making many changes to the application, right? So that's sort of what we've been doing. I don't have a lot of time, so I'm going to just talk about one of these topics, that is say no to the cloud. So we've been working a lot on what I'm calling private intelligent assistant. So the idea here is that instead of doing everything in the cloud, processing in the cloud, answering questions in the cloud, what if I can actually do them locally on my phone? The question, of course, is that cloud, the applications all run really complex deep learning algorithms. They have a lot of data. So how are you going to be able to adapt them to your phone? We worked on 3 projects that actually show you how exactly you can adapt them to the phone. So for example, the first project we did was called FindAll. And here the idea was, excuse me. Okay. Here the idea was, I want to run a local search engine on my phone. So let's say I've already looked for some documents and I want to find it again. I don't want to go to the cloud to do this. Can I just do this locally? And it turns out we can actually do this. Not only can we do this locally, we can actually do this with better latency and better availability than what you will find in the cloud. The other project is called DECA, which is on-device question answering. So the same idea, but instead of search, can I actually answer questions? And answering questions is a slightly more complex, actually not slightly, quite a bit more complex endeavor. So what we did was we looked at question answering, a lot of deep learning question answering algorithms, figured out what the bottleneck was from the system's point of view, and designed algorithms to solve those bottlenecks, and voila, now you can actually answer questions on your phone. Another thing we did was called local news recommendation. And so the idea was, instead of having this aggregation site, and which will then, like for example, Google News, which will recommend news for you, can I actually build a local, like sort of have a slice of the cloud in your computer, and then it will know what your preferences are, and that will recommend news to you. And actually this project, this Priya, we didn't continue too much. Like DECA, for example, we're doing a lot of work in that space now, but Priya, we didn't continue too much because at that time I thought, well, nobody's ever going to use this. Turns out that recently I heard that Brave, which is a new browser, I don't know how many of you have heard about this. This is like a privacy-preserving browser. And actually you're doing private news recommendation and using a setup very similar to what we proposed in Priya. So this was a very exciting time for me. So the takeaway here is it's okay to buck the trend, right? It's fine to go against the tide sometimes. The last thing I wanted to talk about, last but not the least, is that since I joined as faculty, I've been more and more involved in the topics of inclusion, diversity, and equity. I was always aware of the need for broadening participation in computer science. The diversity in computer science is pretty low, and I'm talking, it's a little bit US-centric because I know a lot more about what happens in the US. I've been here for 20 years, so I don't necessarily know what happens in other countries. But here, for example, less than 20% of women graduate with an undergraduate computer science degree. This number is worse for Blacks and Hispanics. And I've been doing a lot of study within Stony Brook, but also with my research community. And especially for undergrad, the biggest problem seems to be retention. And the pipeline is a big issue, but retention is a huge issue that we have to address. Recruitment, of course, is another sort of giant problem, but both of these are pretty hard. But then it actually annoys me that we are losing people who want to do computer science, have been accepted to a computer science program, and then they are driven away. So I've been working on 2 funded projects on improving both mostly retention, but also recruitment of undergraduates. I want to expand this to graduate students and also expand it to underrepresented minorities. And when I started this, actually, there was a lot of pushback because the worry was that I won't be able to do my research if I also do a lot of these kinds of service work. But for the first couple of years, I didn't do that because of that reason. And I didn't want to be called, oh, this is the person who does, cares about diversity, whatever, she's not serious about research. But then I thought about this and realized that I have to be true to myself. I have to do what interests me the most, or what I think is the most important, or where I can serve the best. And so my takeaway here is go with your gut. Work on things that you're passionate about. Do not necessarily listen to what other people say. Anyway, I've given you a lot of takeaways in this talk, but the most important thing I'd say is enjoy your time at BITS. Make a lot of close friends, bare your soul. What I'm showing you here is taken on Diwali in front of the temple with my wing, the 12 of us. I think this was probably taken in 2000. I don't remember. And I'm showing this because this was the Diwali in 2020. We are all still together. We're all still goofing off the same way. And I know that my wingies are always there for me. So this is the time to really make very close friends because they're going to be with you for a very, very long time. Thank you. This is my website and my Twitter feed. I know some of you have sent me friend requests on LinkedIn. Unfortunately, I don't really use LinkedIn a lot. So Twitter might be better, or actually you can just send me email. Again, thank you for this opportunity. I'm happy to take questions.
Thank you so much for this talk, Professor. I'm sure everyone really enjoyed it. We know obviously how busy you are, so we really appreciate your time. And so now we'll be taking questions. So we'll move to the lounge, so we can have a discussion. So people can ask questions, and we can have a discussion on that.
Okay, so, there are a few questions already. Maybe I can answer them and then go to the lounge.
Okay. Yeah, sure.
All right. So one question was, what are some of the ways to apply artificial intelligence to encryption of data so that product can communicate with itself as well as with the server safely? Okay, so this is, there are ways to do this, right? So there are different ways in which you can actually get privacy. One of them is there are these things called zero knowledge proof that people have tried to use, where you can actually encrypt them so that they don't reveal anything, any information, and you can actually ask questions on the encrypted data, for example, on a database. This is a very, very popular technique. Another thing to do would be a hardware device, right? There are these devices that are extremely secure, so anything that goes inside you are guaranteed for it to be secure. So then the question is, can I actually do this entire deep learning pipeline inside that enclave? And if I do that, then I don't have to reveal any information to others. So yeah, there are several techniques that have been designed to do this. Our take on this is that I don't want to go to the cloud at all. I want to do as much as possible on my local device, because that means that I would be able to the availability is also improved, right? If you don't have internet access, you still will be able to access this application. So that is our take. But this is just like there's different philosophies on how to do this, and there's no one correct answer, at least not at this point. Another question is, one of the answers to promote privacy is federated learning. I request you to share more techniques and algorithms. like I just said, these three things are ways in which people have tried to do privacy. Federated learning is slightly different, right? In the sense that the whole point of federated learning is that you want to be able to run everything locally on your device, but your device may not be big enough. So what if I can have multiple local devices and I can run my algorithm on these and then combine them together? This is definitely an interesting idea, but I'm not sure how feasible or practical it is. But we have to wait to see. Maybe this would take off. I don't know at this point. I think that's about it. So I guess we should move to the lounge.
Yeah, just a second. I think there's another question.
Okay, I don't see it. Oh, I see. I have to go up. I got it. Sometimes a product requires multidisciplinary knowledge of AI and MI for young researchers who are starting his sort of journey. Which branch of AI do you recommend? Okay, I'm not sure why you think I'm an AI researcher. I'm not an AI researcher. So I know that artificial intelligence is very popular nowadays, but it's not my area. So I don't know what branch of AI you should recommend, but my recommendation is don't do AI because you think that that's popular right now. Work on projects that are interesting to you. And if you're interested in AI, then figure out what about AI interests you or what application interests you. That would be my best advice at this point. Okay.
So we'll just end the session, and then if you could just join the first table in the lounge.
Sure.